Hi class, so welcome to the last part on the format statements. So as you saw that formatting is a very powerful feature of Python, has unlimited potential and a lot of options that can be given. So without any further ado, let's try to start this tutorial. So now you can see for padding the floating numbers. So I'm writing within the parenthesis colon 8.3f and I'm giving a float number. Let us just increase the length of it. 12.2346789. Okay, so now what does it specify? It says that total of 8 digit space, basically 8 bits will be given to print this, and this specifies the number of decimals. Okay, so here I will have only 3 decimals after the dot. This is the 3 decimals. Okay, so let me try to run the code first. So now you can see 12.235 has only appeared in the output for this particular string. Now why does this happen? Let me just copy the output and explain you. Okay. Control N. Okay, sorry. This is Control V, and we were looking at this particular example, right? So what happens here is we are saying that okay, we are reserving for this float number because your f is there. So for this float number you can have maximum of 8 bit space. So what do I mean by 8 bit space? So now let us count this, right? Okay, so we have, this is the first bit, second bit, third bit, the dot is the fourth bit, fifth bit is 2, sixth bit is 1, seventh bit is this space, and eighth bit is another space. So basically this 8 means I am reserving a rectangle of 8 dots, right, that you can fill up. Just like when you fill bank forms, in the name and all this, you have all these squares, right? So this 8 means, okay, you have 8 squares to fill up and you can have up to only 3 decimals. So what it does, first fills the 3 decimals, right, gives a dot and then specifies this particular format. Okay, so this basically specifies the number of boxes we can use to fill up. Okay, since our number was large, it truncated the decimal points. Because we had 0.3, it kept only 3 digits. So now let us change the number. Let us try to keep it 0.5. So see what happens, the entire space is covered up, okay, and it prints up to 5 characters. As I said in the previous video, since we are reserving only 8 boxes for printing this, see, for example, I keep this as 8.8. Okay, so these are the 8 boxes including the dot, the decimal, and the number itself. So let us keep a huge number, 44, and then let us keep this one. So just check the output here. So you can see we have a total of 8 digits after the decimal because we had used here. Okay, let us take some simple example. We could keep it 9 here and we can keep 5 spaces. So see what happens here, since you have only 5 spaces and the total number of digits, basically this will have 9 decimal places. Okay, 1 dot and the digit itself is 4 digits. So 9 plus 1 plus 4. So you have 14 bits to be printed. But what is the space that you get? You get only a space of 5 bits. So you get only a space of this much. But since the number of digits to be printed are more, we have 9 decimal point digits. We have 5 digits for this particular. We have 5 spaces and we have a dot. So let me keep this as 50. So you will get an idea about how the number is getting printed. See, now 50 boxes are reserved and the entire number can come here because we have 9 decimal digits and the entire real part of the number is printed. Now what happens with this? See, D specifies the integer, right? 5 specifies the width, and what does this 0 specify? Right? We are trying the number 12. So how many bits does 12 required to print? Just 2, right? Like 2 squares are required. So, but the space we are giving is 5. So we have 3 blank boxes. Since we are specifying 0, only 0 will work here, right? You cannot specify 1 or 2 or anything. Only 0 works here. So what will happen? 0 is padded here. Okay. So for example, if I say here, okay, I need a 9 box space here and the number is 12. So what will happen? We will have 7 zeros here. It will pad up the number with all the preceding zeros. You see, all the preceding zeros are filled up here, right? If you don't give any zero here, what will happen? It will give 5 bits, and as we saw previously, the 3 bits will be just spaces. Okay, now what happens with the floating point number? See, 8.3f, that means, and the number is this, I am giving 8 boxes to it and 3 decimal points, right? These are 4, so 6 will basically go. So you can see this becomes 3 decimal points and I have a total of 8 boxes. You can count here, 1, 2, 3. Fourth box is the decimal point. Remember, total width is including the decimal point, 5, 6, 7, 8. Now there are some things which frankly I have never used in my life, but just for the knowledge person. If you want to show the plus sign in a number, so what I'm doing, I'm having a number float, so both are floating point numbers, and I'm saying colon and plus. So what it will show, the number 12.23 is positive number, so it will show a plus bit before it. But see, for negative numbers, what happens? Plus and minus becomes minus, right? So it will just print the negative number as a negative number, right? But if you see this positive number 12.323, automatically there is a plus before this because we have used this operator. Now you will say why the 23 has come as 230000, because by default Python will have 6 digits after the decimal point in a default view. Similarly, if you want to show the negative sign, this is the negative sign, negative sign. So what will happen? A positive number cannot be shown with a negative sign, so the positive remains unchanged, but a negative number is shown with a negative sign. Now show space for a positive sign. So if you want to show a space for a positive number, what do? You give a colon and give a space here. Similarly, you give a space here. So for positive number, you can see in the output there is a single space here. Instead of plus, there is a single space here. For negative, this rule does not apply because it's only for the positive sign. And now what happens with strings? Strings is an interesting case. The logic is same. We are writing the word cat and we are giving a width of 5 to it. So what happens? So in case of string, the padding begins from the right hand side, unlike numbers where we started from the rightmost end. So for example, if you see cat, it is given a 5 box width, but the cat gets printed here from the leftmost position, right? So these are the 2 spaces which we cannot see here, of course. Then we have a string padding with right alignment. Now how do we remember the right alignment? So see, this sign is showing an arrow towards the right hand side. So what will happen here to the cat? I am giving it 5 spaces, 5 boxes, but align it to the right. What happens when you do a right align in Microsoft Word? Everything moves to the right. So you see cat here. So this is the cat having 5 boxes to print, 1, 2, 3 and 2 spaces aligned to the right. By default it's a left align, so you need not have anything for the left align. Then string padding with center align. So for center align, you use the cap operator, okay? And for padding the strings with center alignment, I am using, this is for center alignment and I am padding it with a star. So what happens? I am giving it 5 boxes, keeping the cat in center. So I have 1 character to the left and 1 character to the right, and this is how the printout goes. If you want to check the invisible spaces here for the cat, see, this was the right alignment. I am using it right alignment for 5 characters. So 1, 2, 3 and 2 spaces, right? So these are the 5 width that I am giving, but aligning to the right. Center alignment with 5 characters. So you can see this here. I have a cat and I have a small dot to the left. I have a small dot on the right. So these are the 5 boxes and it is center aligned. Same for the last example, center aligned and pad everything else with 0 or with the star. So this is how cat gets printed on the screen. That's it with number formatting. So there are 4 lectures dedicated to it. As you saw, it's very powerful. Thank you for watching. Have a